Okay, guys. So for this lesson, we're going to talk about variables. I know we've talked a little bit about them already, so you should be a little bit familiar with them. We know that variables represent unknown numbers, right? So anytime you have an x in a problem, or a y, or an a, or a b, you have an unknown number, right? This represents the value of an unknown number. So if I have 2x plus 3 equals 7, I know that x, what? Represents an unknown number, right? Doesn't matter if it's x, could have been 2c plus 3 equals 7. C still represents the unknown number. But we know there are how many c's? There are 2, right? 2 c's in this equation. 2 x's, right? Okay, so we call that number what? Our coefficient. Coefficient is the number that we find right in front of the variable, right? But we think of them as a whole. Units, chunks, remember? Okay. So now, I want you to go ahead and I want you to speculate for a second, and I want you to think. If I have two variables that have different coefficients, but the same variable, so let's say I had 7x and I had plus 9x. Do you think I could combine 7x with 9x? What do you think? I want you to circle true or false on the paper, and then I just want you to jot down a little note as to why. Pause it and do it, okay? Just a little, tiny little note. Just take a guess. Doesn't matter. Okay, so we're going to now transition into talking about like terms. So combining like terms is a way to simplify an expression. Now, when we talk about equations, we're also talking about expressions. So, and when we talk about expressions, we're usually talking about equations. Now, we want to talk about simplifying, because that's the whole point of these things, right? Simplifying them is how we get the variable alone, right? And our goal is to always get the variable alone, right? He's a lonely guy. Likes to be all by himself, those variables, all right? So when we combine like terms, we're going to simplify an expression. Now think about combining like terms. What does that mean? Combine means to put together. Like means similar, right? Like terms. So we're going to combine things that look similar. Did 7x and 9x look similar? Yeah, they both had a coefficient in the same variable. They look similar, right? So if we're going to combine the constant and the variables in an equation through addition and subtraction, we are going to combine like terms, okay? Does that make sense? So, in order to be considered like terms, they have to have the same variable, right? So what if I have 7x and 9x plus 9x, I get what? They're like terms, they both have an x. And we both have a coefficient, right? Means I have 7 x's. 1, 2, 3, 4, 5, 6, 7. What if I add on? Can I add 9 more x's to that? Of course I can. So plus 1, plus 2, 3, 4, 5, 6, 7, 8, 9. How many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is 7 plus 9 equal 16? Yeah, it does. 16 equals 16. So does 7x plus 9x, what do we think it equals? We know, we counted 16 x's, right? 16x. Does everybody kind of understand how I got there? If you don't, that's okay. We're going to go through some more problems, and if not, tomorrow in class, we're going to go ahead and rate ourselves, figure out how we're doing. Okay, so I broke it down a little bit for you. Now, let's see. We're going to go ahead and use some problem-solving skills. Now, I did this example for you. I want you to go through and think. Is 0.75x and 3x. Do we think these numbers are similar? Are they like terms? Are they like each other? Yeah, because they both share the same variable x, right? Don't get confused because the coefficient is a decimal. Decimals are rational numbers. You can combine two rational numbers. 3 is a rational number. Rational numbers are large, big, small, decimals, fractions, right? We know this. So, if I wanted to add 0.75x plus 3x, what do I get? 7.5 plus 3. 3.75x. Okay, now, so this is true. Now, I want you to take a second, think about that. Maybe it's still a little confusing. That's okay, because if we solved for x, it would be the same if I plugged x in here and here. Let's see if x is 1, okay? 0.75x, we're just going to assume x is 1, okay? X equals 1. It's 0.75. 1 times 1 times 1, right? Because x is 1. Plus 3 times x, or 3 times 1, equals 3.75 times 1. Now, order of operations. Multiplication always comes first, right? Before we add. So what's 0.75 times 1? Well, anything times 1 is itself, right? So 0.75 plus, what's 3 times 1? 3. And what's any number times itself? Times 1 is itself. So 3.75 times 1 is 3.75, right? What's 0.75 plus 3? We know 3.75 equals 3.75. Is this equal? Is this balanced? Absolutely, it's balanced. So 0.751 plus 3.1 equals 3.75 times 1. They equal the same. They are like terms. We can combine them. This is a true statement. It is a balanced equation. Okay, now, let's maybe talk about another one. Maybe we have questions like the next problem that we are introduced to. You have an 8y and a 3x. Okay, I've got 8y plus 3x. Now, I have two variables, so I do have variables, right? And I have two coefficients. I have some coefficients. They're both rational numbers. Okay, great. But are x and y the same? No. They're two different variables, right? X does not equal y. They're not the same. So can I combine these two things? No. They're like apples and oranges, okay? If I had 8 oranges and 3 apples, it does not equal 11 apple oranges, right? No way. I still just have 8 oranges and 3 apples, so I just have 8 oranges and 3 apples. I don't have 11 apple oranges. X and Y are not the same. Not like terms. Okay? Not like terms. So, it is false that they are like terms. It is false that you can combine them, right? And 8y plus 3y does not equal an 11xy. Just equals 8 and 3, right? Okay. Does that make sense? Because if I have 8 y's, 1, 2, 3, 4, 5, 6, 7, 8, and I add 3 x's to that equation, does that make 11 xy's? No, it doesn't make 11 xy's. It makes 1, 2, 3, 4, 5, 6, 7, 8 y's, and 1, 2, 3 x's, right? So we cannot add them together. Does that make sense? Okay. I know this can be a little tricky, so let's go ahead and do a practice together. Okay. Let's do a little practice. I have to solve for x. So my equation says 2x plus 1 equals x plus 2. Okay? Now, I'm going to look at this real quick and I'm going to think, whoa, is anything similar in here? Yeah, they are. I've got 2 x's, right, on this side. I've got 1 x on this side. Perfect. Circle, circle. Now, I'm like, oh, okay. And then I've got a constant 1 and a 2, right? Squares, squares. Now, what's my goal? I always want to get my variable alone, right? Perfect. How am I going to get x alone? First things first, I got to get numbers on one side, x's on the other, baby. All right, ready? So, let's go ahead and bring this x to this side and this 1 to this side. So, I'm going to rewrite the equation real quick, you guys. 2x plus 1 equals x plus 2. So if I want to bring this x over, is this a positive number? Yeah, right? It's just x, just positive variable, right? So I got to subtract x because the opposite of positive is negative. The opposite of addition is subtraction. Inverse operations, right? So to simplify this equation, I got to subtract x from this side. And whatever I do to that side, I got to do this side, right? Subtract x from this side. Okay, we know that there's always like an invisible 1 here, right, when x is by itself. So I can do that here too. Now, 1x minus 1x cancels itself out. 0, right? What about 2x minus 1x? Just get 1x, but we can just call that what? We know we can just call that x by itself. Now, what's my next step? Rewrite my equation again real quick. X plus 1 equals 2. Okay? It's positive, right? Now, if I want to get rid of this 1, I got to do what? Plus 1, I got to subtract. Inverse operations. Negative 1. So whatever I do to this side, I got to do to this side, right? Minus 1. This cancels itself out. 2 minus 1 equals 1. X equals 1. Perfect. X equals 1. Now let's check our work. Two times 1 plus 1 equals x by itself, right? 1 plus 2. Now, multiplication first, right guys? Always order of operations. 2 times 1 is 2. So 2 plus 1 equals 1 plus 2. 2 plus 1 is 3. It's the same as 1 plus 2. 3. Does 3 equal 3? Absolutely it does. Is this equation balanced? Absolutely it is. You have the same number on each side. So my first step was I went through and I circled my terms that were similar with had a variable, and I put a square around my other numbers. Separate them off, chunks, steps. Step 2, I combine my like terms. I brought my x to this side and my number to that side. How did I do that? I used inverse operations. What you have to do is remember, whatever you do to one side, you do to the other side. And you're always trying to get your variable, what? Alone. So, once you have your variables on one side and your numbers on the other side, you're going to use your inverse operations. And we did. So, check your work. We did that by plugging this in. Now, let's just go ahead and solve this other one for good times, all right? Now this would be a lot easier when we use algebra tiles, guys. This is just a little video, gives you a little heads up as to what we're going to be doing in class, but don't worry. We're definitely going to be using the algebra tiles for this. So, my equation says negative 2x minus 9 equals 6x plus 15. Okay. Pause. What do you think your first step is? What do we want to do? All right. Guess what? I tricked you. I'm going to let you try to solve this one by yourself, but I'm going to give you a couple of hints. Hint number 1. This is a negative number. Negative 2x. Don't forget the negative. So if you have a negative and you want to bring it over to the other side, you're going to do what? Add. Okay. This is positive 15. If I bring it over to the other side, I'm going to subtract, right? This is a negative number. It's negative 9. If I subtract negative from a negative number, I'm going to have a result that's negative. Okay? Now I want you to solve this one on your own, and I'm going to check it tomorrow. If you have any questions, you can text me on Remind Me 101, okay? All right.